Hello, everyone. My name is Kaitlin Newson, and I'm joined by my coworker Bart Kawula from Scholars Portal. As many of you will know, there's more to hosting technology than just putting it on a server. Today, we're going to talk about our experiences with growing a sustainable publishing technology service for libraries. Our hope with today's talk is to reflect on what goes into technology hosting for publishing services, the workflows we're using, how we make certain decisions, and ultimately the best practices we can work towards with the resources that we have. First, some background on our publishing services. Scholars Portal is the technology service arm for the Ontario Council of University Libraries, or OCUL, an academic library consortium representing 21 universities across Ontario. The Public Knowledge Project, or PKP, develops open source publishing software. Two of the applications that PKP develops are Open Journal Systems, or OJS, which is a journal management and publishing software, and Open Monograph Press, or OMP, which is a monograph publishing software. At Scholars Portal, we provide a subscription-based hosting service for OJS and OMP to Ontario universities. Our hosting service began in 2012 and has grown to 12 universities across Ontario, which collectively host over 150 journals. We host and manage the software on behalf of university libraries, who then run their own individual library publishing programs. Each institution has its own instance of the software. The service is supported by myself, Bart, and a system support specialist. Along with hosting software, the service includes troubleshooting and technical support, sponsored Crossref memberships for DOI minting, hosted Matomo Analytics, an alternative to Google Analytics, preservation of journals in the Scholars Portal Trusted Digital Repository, as well as options for theming and customizations. Over the last 9 years of the service, we've gradually grown from 1 to 12 institutions that we host software for. As the service has grown, we've had to find ways to ensure that we find a balance between doing things sustainably, providing good service to libraries and end users with varying needs and resources of their own, and managing the workload of our team alongside other projects. One way we do this is by leveraging different technologies to support scaling our service, which is critical when our service needs grow, but the number of people working on the service doesn't. We've made use of a number of tools to help us as we scale our service, including tools that help us in the most time-consuming part of the service, client support, which Bart is going to talk about next.
Client support is what takes up most of our time when it comes to our publishing services, and it's become the most critical component of what we do. When we started hosting, we were expecting to only take care of software and maintenance, but as we acquired new members, we found that there's a whole layer of technical support around making the software do what the users need it to do, rather than just using it the way it's intended to be used. Over the years, it's become apparent that for technology to be fully utilized, there needs to be a strong support component, because the more journals that are added to each instance, the more the need for client support grows. Like in most library IT departments, no one person does one thing. People get spread across projects in order to create redundancy, which is critical for providing scalable client support. Since Kaitlin joined our team, we've been better able to balance our publishing efforts with our other work responsibilities. From a practical point of view, this means that we can answer most support queries within the same business day. Typically, when an email comes in, we use our internal chat system to decide who can do what based on current workloads. Support requests can range widely from simple interface or workflow questions that require a few minutes to answer to more involved systems level issues that can take days to resolve. As you can see, time and its constraints are the main thing for us when dealing with client support, which is why we try to track it. We use the built-in time logging features for Jira. For those of you who aren't familiar with Jira, it's a ticket management system that also works as a project management tool. So every time we answer an email, we log the work we do associated with that request with both a description and the time spent. It's very tedious, but it's critical for determining the amount of resources you devote to something. And when you have solid numbers, you can critically evaluate the sustainability of what it is that you do. Using a full year's worth of work logs, we were able to see that the amount of time we were putting into our publishing services work wasn't being recouped by the $2,500 annual fee, which was a bit of an arbitrary figure to begin with because we weren't sure of the real costs of running the service when we started. Given our data, we saw that we needed to cover at least one half-time position. We debated various pricing models, including charging hourly in addition to our base fee, but managing billable hours can get messy, and we noticed that there was a strong correlation between the number of journals that a library supported and the amount of support hours dedicated to that instance. In the end, we went with a base price plus number of journals approach, which we proposed to our members, and nobody seemed bothered by it because we were able to show exactly how much work goes into sustaining the service for each member. Working with our members is our main focus, and we enjoy developing our relationships with them. Each of our relationships is unique, and we like to think that we offer a bespoke level service geared to the specific needs of each library. But as membership grows, as well as the number of journals each member hosts, it's become important to have clearly defined roles and responsibilities for everybody involved. It's important to establish the roles early on and clarify who is responsible for what, because defining roles is easy, but redefining roles is hard. For example, we've had cases where editors will start to contact us directly for support, and it can be hard to go back. Sometimes it's easier to just work with the editors directly, but it sets a bad precedent because we simply wouldn't be able to handle the amount of support work. This is why we insist on only working with scholarly communications librarians who do the remarkable job of handling all of the training, journal setup, and management aspects of publishing, while we support them on the systems side. Nevertheless, situations arise where the librarian we work with goes on leave or moves to a new position and there's a gap in service. In those situations, we do offer to work directly with the journals with the understanding that it's only temporary. One of the best things about working with OJS and open software in general is the community. We encourage our members to get involved in the broader journal hosting community with things like mailing lists, Slack channels, and forums. We don't always have the answer to questions that come up, especially because we don't typically work with editors or within the editorial process. So involvement in these communities is important. Nothing makes me happier than getting an email identifying a bug that includes the forum thread discussing the issue and the GitHub pull request for fixing it. And now, since we're on the topic of fixing code, let's segue into code management. When thinking about code updates, we work closely with institutions and monitor the latest developments from PKP so we can make judgment calls about when to upgrade. Some things that we think about include, are there security issues? What are the new features? Is it a minor release, or are there known bugs in the current release? If it's a security issue, we obviously prioritize that immediately, but minor bugs we tend to fix on an as-per-need basis. Oftentimes, if something comes up and there's a patch, we'll just patch the reporting instance because those fixes will most likely be in the next code update. When it comes to major release updates, each member is different. Some might be eagerly waiting on new features, while others like to wait a few months because they might not want to potentially disrupt a busy editorial cycle. From experience, we like to wait too because there's always a few kinks that quickly get fixed after each major release. But again, if a member is eager, then we work with their needs. At the moment, each of our members has their own code repository because of the inevitable code customizations that have accumulated over the years. This means that updating code has been a manual process where we pull from PKP and merge local changes into our repos because it preserves all of the customizations. With 12 instances, this takes a bit of time, and so with our latest upgrade from version 3.1.2 to 3.3, we're finally moving to a single code base shared by all of the instances. This is no simple feat, and it's taken us years to get to a point where everyone can use the same code base. In the past, we allowed for most customization requests, but as the service has grown, managing these has been challenging. It's important to remember that every code customization has a cost associated with it when we're upgrading because we need to reapply or merge these changes with each upgrade. With all that in mind, we're trying to rethink how we handle customizations. Some of the things that we think about include, could this be useful to the larger project community? Can we submit this back to the main project? How large of a change is this? Can it be contained within a custom theme plugin? And finally, does it create technical debt? Technical debt is essentially kicking the can down the road where easy fixes today become a burden in the future. And now finally, Kaitlin will be discussing the nitty-gritty details of how we deploy our code in our next section on environments and deployment.
In the past, we used to do our test upgrades locally, but as the service has grown, we can't always do this on our own machine. Some of the reasons that this can be challenging include the size of files on each instance, which are too large for a small laptop hard drive, and the length of time an upgrade can take to run, which requires a more reliable environment than a 2015 MacBook. Development environment allows us to test upgrades more easily and to open testing up to users before updating production. This is especially valuable when a new version of the software is released that introduces major changes to the user experience. This is also a space for each institution to work on custom developments in an environment that mimics their production space. One thing to note is that you have to make sure to set up the development environment properly. This means things like turning off system emails, making sure data isn't being sent out, and ideally limiting the environment to certain IP addresses so users don't find it accidentally and it isn't crawled by other websites. When we migrated to OJS 3, we made our production environment more efficient by moving from individual servers for each instance to a shared server which works for OJS because it's not that resource intensive from a technical perspective. By moving to a single server, we removed the need to manage 12 servers for the service and reduce the maintenance workload for our systems team. It also ensures that we don't have differences between servers that can cause issues, like a package that's been installed in one server but not on another. This is a snapshot of our deployment documentation for OJS. In the past, we've relied on lengthy documents that outline different steps in the upgrade process. This process may be familiar to you if you've ever been responsible for managing hosting software. This document outlines all of the different commands that we ran to upgrade OJS on a production server and has many more steps beyond what's included in the screenshot. The problem with this process is that it's prone to human error and it can be easy to enter a command incorrectly or miss a step. While we have backups in place, it adds a lot of time to the process if we need to restore something, and it's tedious and time consuming to do this multiple times. To improve on this process, we started using a tool called Jenkins. Jenkins is an open source automation server for deploying code and automating tasks. At Scholars Portal, we host Jenkins and use it across many of our applications and have started to use it with OJS. This is a screenshot of the Jenkins interface with a list of different jobs that we have available in the system. Each job represents a script that strings together different commands. Jobs perform different functions, like deploying code to a server or running a script to download data. Without a tool like this, someone would have to run various commands individually, and the process would be more time-consuming and prone to human error. Jenkins provides a number of other valuable features, like scheduling jobs to run at certain times and rolling back to previous versions when there's an error. In this screenshot of our Jenkins workflow for our development environment for OJS, we have a drop-down menu that allows us to select which school's instance that we're upgrading. We can then enter the code branch, in this case for OJS version 3.1.2, and we have a checkbox for pulling in the latest database from our production environment, and another if we want to run the upgrade scripts. We're currently using this in our development environment, but hope to roll this out to production after we test it further with our next upgrade. While the change might seem minor at first glance, it will save us a significant amount of time when we have to upgrade our OJS instances. Instead of running a series of commands 12 different times, we can do the same series of tasks with a few clicks on a web form. The last topic we'd like to touch on is getting involved in a larger project or community. In order to grow services that are built on an open source code, it's vital to give back to that project when and if you can. Giving back to the open source software that we build our services on both helps our own users and builds on the sustainability of the software for the long term. Many open source projects are facing their own challenges with limited resources as well. In the case of our publishing services at Scholars Portal, this means finding ways to contribute back to PKP and the user community. This can include things like participating in the PKP forums to help other community members, contributing code or documentation back to the project, especially when our users find bugs that we can resolve, being involved in working groups and communities. For example, we're involved in PKP's documentation and metadata groups. Contributing financially back to PKP. Thankfully, many institutions in Ontario have been willing and able to contribute to PKP financially, which can also give us more opportunities to advocate for our community's needs and priorities. Finally, another way we can support scaling scholarly infrastructure is by supporting broader initiatives in this space, like the Library Publishing Coalition. Another example is the Invest in Open Infrastructure project, which is an initiative dedicated to improving funding and resourcing for open technologies and systems, supporting research and scholarship. The Invest in Open Infrastructure project is one example of how we can broadly support efforts towards more sustainable and scalable scholarly infrastructure. That brings us to the end of our talk. If you'd like to contact us, you can email us at ojs@scholarsportal.info. Thank you.